Fine, so we get started. Yeah, we understand. So this is actually going to be a 4-day workshop. Okay, and first day it will be on uh, generics and collection. Okay, and second day it should be on functional interfaces. What is lambda expressions? Okay, fine. Then we have uh, Stream API, right? That's one thing which is making Java very powerful. That's a feature introduced in Java 8 basically. So we have a library uh, by which, you know, any kind of processing on multiple elements, how to make it. There's a lot of standardization to so that your code, you will be able to write very small code doing a lot of powerful things. Okay, fine. So that's one thing, and then there is some advanced usage of the streams that we'll be covering later. Okay, and so that way we have 4 days, and anyway, in between, if you have questions which are related or somewhere near around this, you can ask questions anytime. Fine, and don't restrict to whatever I'm teaching here. Okay, you can ask questions from anything. And yeah, yesterday I think I had sent. I have created one GitLab account. Okay, one GitLab project has been created where I have sent some source code already. So have you seen that? Gone through it? Anyone? Okay. And so initially, yeah, if there are, is there any difficulty in understanding what it is currently doing? Because this, the idea is that I have some simple starting point where I would like to add concepts through exercises, and that's what you will do in the workshop. Okay, so keep on building on whatever is currently there. So it's important that you understand what is currently there. Anyway, before we begin, I think what I'll do is, uh, you have any questions to ask? Anything? Yeah, any one of you. If you have questions. Or okay, let me begin with a question then. Okay, yeah, I'll be creating notes, and this also I'll be sharing. Okay, and so let's begin with some question which is not related to the topics in the workshop. Okay, sorry. 1 second. Yeah, something else. Okay, I'll write some code, and then I would like you to know like what should be the result of that code. So I'll not write the whole, okay, I'll just write the main method here. And we have, yeah, okay, and okay, the idea is here something like this. Sorry, A divided by B. Okay, and we are saying system dot out dot println and C. Yeah, just print C. Okay, so we can do numbering of lines. Want me to do that? Or I think this is your line 1 is public static void main. Okay, fine. So you can count from that 2, 3, 4, 5, 6 lines total. And now your choices. Okay. Four. Okay. Where we have done the division. That's one choice. Another one is it says okay, no compilation, no error. Or okay, second one can be error at runtime. And that's for the arithmetic exception which we are expecting. And third option is no error. No error at runtime, compiles and executes fine. Yeah. Any other option? If any, if there is, if someone says anything else, yeah. So yeah. So what do you think? A, B, C, or D? Question is clear, right?
C.
C. Okay. And so
I doubt.
yeah.
सर ये लाइन पे एरर कैसे आ सकती है? देखा जाए तो लाइन 8 पे आनी चाहिए ना.
Okay, okay. 4 means I'm counting this as I said this. Okay, let me do it this way. Because I don't want to use those line numbers of the editor. This is 1, okay, this is 2, this is 3, 4. Keep it this way, okay. So line numbers are here with the colon. Okay, so line numbers are on the left hand side because and the other line number is the line number within the file, as I'm not looking at that line number of the notes, but rather line number within this code block. Okay, yeah. So it's this line we are normally really talking about, right? So how many feel it's we are doing a division by 0, so how many feel this is an error, and how many feel that okay, no compilation error, no error at compile time or at runtime also? You can put on the chat, I think, and then I can know. Yeah, let's see. A, B, C, or D? I think, yeah. And one more thing, if it is, even if someone says C, then you tell me what's the output. If there are no error, what is the output?
Output will be infinite, sir.
Infinity. Okay, correct. So you already know about this, that is, right? Yeah. So with double, the only concept I wanted to let you know was, because many times this is missed out. Okay, normally people think that, okay, oh, when you divide by 0, any division by 0, it's an error. That's an error when you deal with the whole numbers. Okay, but not with the floating point types like float and double. In case of float and double, there is a representation for the special numbers, special values, the positive infinity, the negative infinity, and not a number. You know what is not a number? How will you get not a number?
Not real numbers.
Yeah, you get a positive okay. I'll use one more tool here. I'm not sure whether anyone ever used J shell anytime. Any of you has used J shell? Okay. This has been there from Java 9 onwards. It's from Java 9 onwards. It's available as part of the JDK. Okay. Fine. So let me go to the command prompt and show you how we can. So you can see the results and everything right there itself. So you just start JShell, just similar to when you start, you get Python prompt, right? So like this, okay, this is our JShell prompt. So here you can try out expression statements and write some small pieces of code and try them. Okay. And so simple utility. This is from Java 9 onwards. Okay. Fine. So yeah, we what was our code? We said okay, double A equal to 75, double B equal to 0, double C is equal to A divided by B. This is what we were doing, and you can see it shows infinity, right? Same way. So there are three special values I was talking about. What would happen if I had A equal to minus 75? And then carry out C is equal to A divided by B, it shows minus infinity. Okay. Let me clear and okay. It's not showing the full screen. Okay, I'll just clear it and start again. Yeah. Okay. So let's make A equal to 0. And now what should be this? A divided by B. B is 0, A is 0. Is it infinity or minus infinity? NaN. NaN stands for not a number. Okay. NaN is not a. Anyway, okay, so this is just some concept like that floating point. You have these special values: positive infinity, negative infinity, and not a number. Okay, fine. Let's proceed now. Yeah, anyone has questions on this? No.
No, sir.
Okay. Okay, so let's start our day with generics. And we'll start with, okay. So, yeah, have you done generics, some part of generics earlier? No. Achha, not at all, or some things were done?
Nothing.
Okay. Okay, so yeah. I'll come back to the slides also here. Let's proceed here with the slides here. Okay, so yeah, here we'll start with source code. Yeah, so there will be something like we need to understand the source code. Okay, so generics is about having type parameters. What do we understand by parameters? You have done parameters with methods. In Java, following things can be generic, and these are the four things which we can say they are all generic. Anyway, the thing which I have introduced, saying okay, this is from Java 16. There's something called a record which has been introduced. In Java has now something called records. That's from Java 16. What is the current version of Java? Anyone is aware? What's the latest version? Which is the latest version of Java? 22.
22.
Yeah, and that came in March this year. Okay, fine. Okay, we normally stick to using the industry would stick to using the LTS version. Okay, long-term support version. So the latest long-term support is 21. Okay, after every 2 years there's a long-term support version, LTS version. Fine. So just making you aware of this. Okay, fine. So anyway, record was something introduced in Java 16. So LTS 17 would be the one which would have that record thing if you are looking at only the LTS part. Okay, LTS would be Java 11, then 17, then 21. Okay, these are the LTS releases after Java 9. Okay. Okay, so yeah, so it says generics is about having type parameters. So what is a type parameter? What is a parameter? Yeah, you have seen parameters with methods, constructors. Yeah, so many places we use parameters, but there's some difference here. Yeah, those parameters are for values, right? But here we are talking about parameter for types. Okay, I'll come back to notes. Okay, okay. So it's all about type parameters, and okay. Okay, okay, so we want to have type parameters, right? The idea is to have a type parameter. You understand data types, right? What are the data types? Which yeah, two broad categories of data types.
Primitives and the reference.
Yeah, primitive and reference type. Okay. Okay, so now when we are talking of type parameters, it's related to the reference data types, not about the primitive types. Okay, it's not for the primitive types. That's one thing. Okay, fine. Okay, so let's start with a simple case. Why is something like a parameterization of a type may be required? Okay, fine. So maybe we develop a class. I'm just taking this is not an example for actual usage purpose, just for the understanding purpose I'm introducing this example. So suppose someone is developing a class called account. Okay, yeah, and what are the variables you will have? Instance variables. This is maybe a public class account. What would you keep? A private variable for variable will be there for account number.
Yes.
Okay, so okay, I'm putting account number. I'm not specifying the type currently. What should be the type? Now tell me, what should be the type?
It should be like long or something because integer has limitation.
Okay, yeah, long, so that it can be integers will be 9 digits are fine, 10 digits, not all 10 digits can be covered, right? And our account numbers are running into 10 and 11 digits now, right? Bank account numbers, yeah, we are talking about bank account numbers. Okay, so but someone will say, no, we should we not keep it as a string? Yeah, that can be an argument. Okay, so currently let me leave it here. Other attributes may be like, okay, we have private, you have decided name should be a string. Okay, right? But for account number you're not sure, and for some reason the one who is developing the account class, okay, someone who is developing an account class thinks that the one who will use the account class, let him decide what he wants. We want the decision to be taken by the one, so we are not fixing it to be a long or a string. We don't want to fix that. We say, oh, it can be decided by the one who uses the account class. Here there is a difference between the developer of a class and the user of a class. right? You know, a reference type, a class is a reference type, right? All classes are the reference type, right? Any class you define, that's coming in the reference type section. Yeah. Okay, so account being a class, it's a data type, and we understand someone who writes a code somewhere else, right? Now someone will be using account. How will you use account? Okay, so for usage purpose, there'll be other things as well, but then you might say, okay, let's have a public method to return called get account number. I have not yet written the return type. Okay. What is missing in all of this is I have not mentioned the type here still. Okay, and then someone says, okay, that's one thing. Someone says, oh, we may even have a constructor for the account, okay, which takes as parameter, I don't know what the type is, but there is some account number to be taken as parameter. I'm leaving that type currently as blank. I'm not specifying, but second parameter will be a name. Okay, let's keep it like only 2 parameters. There might be some more parameters as well, but okay. And your code for this one thing, what would be the type here? The type here would be same as whatever is the type for the account number, right? That same should be the type for the first parameter in my constructor. Okay, I'm not specified. That same should be the type for my return type of the method. Okay, but I can easily write the code like this dot account number, because the types are same for account number and ACNO. I can write like this. Assignment is valid. This dot name is equal to name. Yeah, this kind of code we know, right? So this is something which can be done, but yeah, of course, what we have not done here is not specified the type of, this will not compile because everything needs a type. Now, what I want here is, I want to say, no, in my account class, I want to have a data type. Okay, I want to have a data type which is a parameter. And that means it's going to be different each time someone wants to use it. How do we use this account class? Yeah, someone will declare, right, account and say AC1, AC2. That's a usage, right? Someone develops the account class and then starts using it. So someone writes a code like this, right? And then he'll say AC1.getName. So when he says string, S is equal to AC1.getName. Yeah, that's one thing, right? But what about what should he do when he wants to get the account number? Oh, getName method I've not written, but anyway, you can know that, understand. So something like I want AC1 dot get account number. What should I assign it to? Yeah, what do you think should be the assignment going into? What's the type? Type not known, right? But what the whole idea was that it is the user of the account who decides the type. See, here is this code here is from the developer of the account class. Okay, the code which I'm writing here is the user of the account class. He is starting to use that class which has initially been developed with some methods, with a constructor. Okay, fine. So you can see the clear distinction. So we want to parameterize what is the data type for account number. Okay, to the extent that someone says, okay, in case of AC1, I want the data type for account number to be something. For AC1, I want account number, okay, should be of type long. Okay, and I want another declaration of account AC2 where I'll say account number should be of type string. See the requirement of the user. So we are leaving it to the user of the account class to decide. Okay, I have not yet completed the code. Okay, but just giving you the idea. need the thing. So if I'm doing like this, then it would be long ACNO equal to ACNO1 equal to something like this. And what will be the other code? If I use AC, if it is AC2 dot get account number, I should be taking it with the string. Clear? So what I am now trying to say is that yes, I should be mentioning when using the account class that this is to be used where account number is of type long, and this is to be used where I want account number to be of type string. But how do I specify this? So for that, we create what is known as this class should make a provision for A. Okay, I'm just writing capital a single letter A. Okay, this class here, when it mentions like this angular bracket and specifies some identifier, capital A is an identifier, fine. This is nothing but, what is account class now? Account class is a generic class. Why we say it is a generic class? Because it uses a type parameter. It has a list of type parameters. There's only one in this case, but there can be multiple also. Okay, so what is A? It's a type. So wherever I want that parameterized type, that something which is decided by the user of the class, what is the type for account number? It will be A. What will be the return type for get account number? It will be A. Okay, what's the parameter in my constructor? It will be A. Clear? What is A? It's not known to the account class. When account class is compiled, it is not known what is A. Clear? What is the concept? The concept is someone wants to parameterize the data type. Normally we were parameterizing with methods, parameters in a method, they are nothing but your values, right? They can be objects or something, but here we are talking about a data type. I want to parameterize a data type. So this is A is a type parameter. Okay, fine. So any class which uses type parameter, fine. How do we specify type parameters for a class? By using angular brackets. Okay, and you can have, here I have used only one type parameter, you can have multiple. Okay, I have used capital A, it's a convention. You understand the conventions? If you have a class name or interface name, you always start with a capital letter, right? The convention for type parameters is we'll use single capital letter normally. Okay, it's not a must, it's just any identifier, but to make things so that otherwise it can be very confusing, fine. So for that purpose, it has been a convention that type parameters, whenever they are used, they will be using single capital letter. Okay, so most fine. So from compiler point of view, it's not a requirement. Okay, but yes, as a good coding practice, yeah, you should be doing a single capital letter for the type parameter. When the concept is clear, what is a type parameter?
Yes, sir.
Okay.
Yes, sir.
Fine. So now you can see this. What's the return type for get account number? It just simply says return this dot account number, right? So here when someone says this dot account number, what's the return type? A. What is A? It's not fixed, it's decided for each variable. For AC1, the one who decided when someone declared AC1, he declared and said, okay, for AC1 it's long, for AC2 it's a string, right? And therefore, if someone says AC1 dot get account number, that's of type long and this is of type string. Of course, what we have not yet done here is we started using it without creating the object. We should have actually done AC1 equal to new and then account. Now for AC1, what should I be doing? There is like we have to actually use this because it's a generic class. Fine, you put the angular brackets. You can even mention that this one for AC1 it is of type long. So here you should pass a long value. Fine, we understand there's an auto boxing conversion which will happen. Okay, and second parameter can be any name. Okay, fine. Okay, so AC1 can be like this. Similarly, you create AC2 also. Right? So when you say new account, okay, here you should be passing a string. Okay. Fine. So clear, it's okay. So the whole idea is when you define a class or even an interface or even a record, right? A record anyway, you may not have seen, but you know about class and interface, they can have type parameters, which can be used throughout the definition. Clear? It's used just like any other reference data type. Okay, now my question here is, okay, so so now a question here. Okay, so we have account number declared as of type A, right? And then someone is writing a public void some method and he says this dot. Now the question here is, on account number, which methods can I call? I want to call some method. Which are the methods available on account number? Oh, it is decided by the type of the account number, right?
Yes.
So I don't know the type of the account number. It can be anything. It can be any reference type. Yes. Clear? What can it be? See, the developer of account class, he will not know what is the type for account number. He only knows it is some reference data type. Okay. So if he wants to call a method on that, which are the methods available to him?
Like toString, dashboard.
Yeah. Any method of the, yeah, you have said object class. Okay. Clear? So this A is usable as only as object. Clear? For fine, this is clear? Okay. Fine. So okay, so that's what can be done here. Fine. And whatever parameters necessary may be done. So methods of object class only can be used here. Okay. So usable only as this, right? But as a use, so this is the difference you have to understand. There's someone who is a developer of a class, and then the others are the user of the class. Use the class usage. When the class usage takes place, it is must that he must specify the value for the type parameter. Value, not value, exact type, actual type for the type parameter. Okay. Now, okay. So we understand that we can have classes which can be generic. We can even have interfaces which can be generic. Okay, fine. And there can be multiple type parameters. See, another very commonly used example for generics would be someone saying, oh, we have a public class called pair of k comma v. Okay, some key and value pair is being created, right? So I have two type parameters, one for the key type and another for the value type. I'll say I have a private variable k for the key and I have a private variable v for the value. Okay, so there are two things, get key, get value, such methods can be there, right? But now you understand this, right? So when someone wants to use the pair, he will say, oh, pair of integer comma string. Okay, so that can be usage. That's one way of using it. This is my pair 1, p1. And whatever constructors are provided. Yeah, this is where we call as invoking the type, generic type. Okay, fine, because here you are using the generic class or generic interface. Okay, generic type is being used. Classes interfaces, whichever type parameter, they are the generic types. Fine. You could even, for an integer, someone says, no, I want to use an int array here. That's fine, because that's a reference type. Clear? Reference type means anything. Okay. Okay. Clear? Any questions? Yeah.
Sir, why primitive types are not allowed like something?
Okay. See, one thing we saw, how do we use that account number?
Yes, sir.
Any method of the object class. Get it? It's a reference type. Then, we have a way of using it. Okay, we know how it can be used. See, I'll tell you what exactly was happening was, we had classes, okay, where, for example, I'm not sure whether we do have something like, okay, I'm now giving you a version which is pre-Java 5. Generics came from Java 5. Remember this. Java 5 is the time when generic got introduced into Java. So Java didn't have generics earlier, prior to Java 5. So prior to Java 5 also, we had that same interface called collection. Okay, we are going to come to collection later. C1. Okay. And what the collection interface was providing was, it had a method. Now just see, what was done was, we had a public void method called add, and you can give any object. This is how it was. Okay, and you had a method called return, not in, it was instead of collection, let me make it list. Okay, so in list we had a method to get the element. So it would say, oh, I have a return type object, name of the method is get, and I can specify integer for the index value. So in a list, you can add, so it will always get appended at the end, or you can, from a particular index position, give me the element. So elements were there, the whole library was built with object. Okay, it was done like this. So later what they said, okay, just understand that when we use arrays, we know the type. We use, these are data structure. List is also data structure. So why not we have something like saying, oh, so I'll just copy this and just see what's being done. What they did is they said, oh, no, why not we make it as some element type E. So when you add, you are adding an object of type E only. Okay. So in a list, you won't be adding anything which is, so if a list, so the user of the list, see now, this is list, someone who defines as an interface, he has defined a method, right? But someone who is a user of the list, okay, he will say, I want this to be a list of integers or list of strings. Okay, names equal to, and he creates And we are not looking at currently how it is being done. We will be looking at this collection framework. Though I've taken the example from there. Okay, and then he will be able to say names.add, then he just directly uses a string. And when he uses a get method, okay, the get method return type will be E. Sorry. So this is how the things changed. Add method parameter, no, it's not object. This was created general, right? So now it's like, type checking can be done by compiler itself. Internally, let me explain. Internally, wherever you have used a type parameter, okay, if I come back to this same example of account, when someone declared account number as of type A, when account class is compiled at that point of time, the compiler doesn't know what is the data type for A. It only knows it's a reference type, internally declares this to be an object. Internally, that's how it is compiled. Okay. Because the type is not known, right? It's decided by the user, right? So when someone is starting to use, it's only at runtime, okay, that the things will happen. But compiler, because he's already told, compiler can do some initial checking that he's using it correctly or not, right? For example, get account number, internally account number is object, but get account number, fine, he's saying, oh, you don't need to cast it, fine, because the return type is mentioned as get account number says return type is A. So if you have a AC1 as your account number, fine, if your account type is AC1, for AC1 what have you mentioned, long, yes, then I will always do a check that A is always used as a long type or not. If it is used anything other than long, okay, fine, then I have to give you a compilation error. If it was internally kept as object because you want to allow user to use it like whatever he wants, right? He wants to keep a string, he can keep a string. He can, if he wants to use a long, he can keep a long there, right? But then someone could have just said, okay, why not declare it as object? Right? But then the type, the compiler would not be able to check. Okay, here compiler is able to do the checking, extra checking at the compile time itself is done. Fine. Rather than someone doing a casting and then getting a class cast exception. Okay, one more thing. So, fine. So, this is clear, right? Type parameter concept is clear.
Yes.
Okay. So, any other question? Yeah. Why not primitive? Because this was basically meant for this purpose. The whole idea was that it was some object which was being, how people were using was object and it was to be replaced. And mainly this was for the data structures. What has been mainly affected by the generics is the collection framework. You haven't yet seen the collection framework, but yeah, that's the place. So it's like list, set, map, and all such kind of data structures are there. Hash table, you understand the data structure, right? So map is nothing but similar to a hash table. You have done data structures, right?
Yes.
Okay.
Yes.
So it's basically those implementation of data structures are available, and so when you say data structures, they were initially designed for object class, keeping in mind that okay, people should be allowed to use whatever they want, right? So a data structure will hold any kind of object, but then normally we use it with a similar kind of elements. Okay, so why not declare it? Okay, that was the whole point. The user declares how the data structure is to be used with. Okay, okay, fine. So this one is okay. Okay, so fine. See, this list, whatever I have used, basically is also a interface. Fine, I have used list, but that's basically an interface. We'll be looking at it later when we look at the collection part. So classes. Okay, they can have type parameters. What else can have type parameters? Methods can. Right? Even methods can be generic. So how do we write a generic method? Okay, see, syntax wise, you have understood the syntax for a generic class or an interface, right?
Yes.
Okay. Yeah. So syntax wise, let's understand. It's what is needed is being able to provide a type parameter. So I'm writing a public static method maybe. Okay, I'm just using static, but may not have been static. The whole point here is after the modifiers, but before the return type. Okay, so there is some return type, maybe return type is void. Okay, and some method is there. Okay, this method I want it to be a generic method. Okay, that means this method has some type parameters. Okay, there'll be some this can have parameter list, which I have not yet mentioned, but this I want that it should have some, I want to have some type parameters. Okay, so they can be specified before the return type. The type parameter list for a method, for a generic method, is specified just before the return type. So before the return type here, this is the place where you can say, oh, I have some type T, which is a type parameter, and I'm saying, okay, so I want first, I will be passing you an array. Okay, fine, array of some elements of some type. The array may be of element of whatever the type is. And second parameter will be an integer for the index. And this method is supposed to print or do something with that particular element in that index. But it's the same for any kind of an array. I don't want to write that some method to be overloading it, right? It should be written differently for string array, though I'm doing almost the same thing. Okay. Here, maybe someone does system.out.println. A very simple thing, array of index. Something like this. Okay. So this is a generic method. What is the type parameter? T. Okay. So when this method is invoked, it can be passed any kind of an array. Okay, this doesn't seem to be much useful anyway, but we'll realize later. We'll have examples, actual examples in the Java API, Java library, where generic methods are useful. Okay, we will have generic methods. The syntax, from syntax point of view, understand the list of type parameters. Here I have only shown one type parameter, it can be multiple. It is specified before the return type. After all the other modifiers are done, okay, and before the return type. This is return type of a method, right? So that's a time when you have to specify the list of type parameters. Okay. And suppose someone is invoking a type parameter. Now this is not necessary, but from syntax point of view, if someone wants to call that method, this method happens to be in some class. Okay, if this is how it is, right? Okay, so if this method happens to be in some class, if someone has to invoke the method and want to specify the actual type, he would say some class dot and then specify string. Okay, and then pass a string array. Okay, fine. Here he should be passing a string array. Something like this. Clear? So it's a static method, so class name should come, right? But just before the method name, you specify your actual type parameter, actual type. So this I want to use it for a string. Okay, one thing, even if I don't mention this, it's fine. It's going to work. It will automatically infer that this requires an array, and that array happens because you have passed a string array. Okay, that T is a string. You don't have to mention what is that T for. Okay, when this is not necessary, but I'm just giving from the syntax, actual syntax point of view. This is what is the syntax. Okay, but this is normally not required. We do not normally use it, and the compiler is able to understand this. Okay, generic method. Clear? What is a generic method? Syntax point of view, generic methods are now clear.
Yes, sir.
Okay. Okay. Now coming back to the generic class. Okay, I'll just because yeah, there are a few things about the usage of the type parameter, how it can be used. Okay, so if I am having a public class, with some type parameter t1 and t, and I'm just saying t1 and t2. Normally we say t comma u and like this. Yeah, we can do it like this also, single, keeping it single letter only. Okay, so if I'm having something like this, within this class, how t and u can be used and what are the restrictions on them? Okay, are they just any type parameters, any reference types? Okay, from the point of view of usage, yeah, we were looking at it that one thing was methods. Yes, we cannot have we cannot be invoking method other than method of the object class. That was one thing we found out. Okay, so within this class, can I create object of the type t? You don't know the type, so fine, we cannot use new t, invoking some kind of a constructor or anything. So what is not allowed? Okay, we cannot use it in a new. Okay, no array creation. Okay, fine. So you can't say new and create an array with it. Okay, cannot be used in a static context. Okay, so if someone says, we used account number as of type, whatever was the type parameter, right? But someone says, I want a public static variable, and maybe I want to keep it final, and I want it to be of type t. Okay. And maybe I'm trying to assign something here. Yeah, someone says like this. This static is not allowed. In a static way, it cannot be used. It cannot be used in any static context, not even inside a static method. No, if there is a static method of this thing, right? If there is a public static method in this class, oh, someone says public static void main, right? Yeah, you may be writing that public static. It's a static method. Here, T and U cannot be used. Fine, cannot be used inside a static context. Okay, so remember these three constraints for the type parameters. Okay, fine, cannot be used. These are all what cannot be used. Okay, I'm just putting that comment for that. See, why? Because basically it's not related to, it's related to objects. The type parameter where the values comes because of the objects, right? If you recollect how we had used it by saying, how did we use it? Oh, we have to specify a variable, right? So we declare some reference. That's the time when we invoke and specify the type. So type parameter is for this specific instance, right? Here instance has not been created, but for this specific reference. Okay, AC1, which means there has to be some object for which it is working. Clear? It's not without object. And when we say static, that is, static is used without object. Clear? So type parameter are not available when someone uses static. Okay? Yeah. Yeah, any questions? Yeah. Okay. Now I'll show one more aspect about the type parameters. Okay. So for that, I'll again rewrite the account class, but this time public class account. Okay. But with a different thing, we'll introduce one more instance variable. Let's not have type parameter for the account number and the name. Or you want for account number, let's keep A. Name, we are not keeping any type parameter, but we also maintain a balance for the account. So let that be B. Yeah, what should be the type for the balance? Data type for balance.
Double.
Someone says long, someone might say it should be double. Someone will say no, let's keep it as big integer or a big decimal, because it may overflow. Our balances can be more than 18 digits, right? So if it reaches 18 digits, even the long will not suffice, right? And therefore says, okay, let's leave it to the user of the class to decide what he wants to keep for the balance. What should be the data type for balance? Let it be decided by the user of the class. Okay, I'm not doing anything related to A here. Okay, fine. I understand that we have already done it, right? Okay, I'll just declare private A for the account number. Okay, name is also one of the fields, all that is fine, but I'm saying private B for the balance field. Now, does it sound good? Is there something wrong by saying, okay, balance should be of type B? I'm not interested in fixing the type. I don't want to fix the type in the account class. It should be decided by the user, but I have still some constraints about the balance. Yeah, what should be the type for the balance?
It must be a number or something.
It must be a number. That's the whole idea. So how do we specify that it must be a number?
It should come under any number class.
Bounded, we have something called the bounded type parameter. Okay, fine. Bounded type parameter. B should be a bounded type parameter. Acha, number, it should be a number, right? So I thought you know that the number, what is a number? There is a class called number. Are you aware there is a class called number?
Yes, sir.
Okay, fine. It's a superclass for the 6 wrapper classes, plus there are many other subclasses of number, right? You know the wrapper classes? Byte,
Yes.
short, integer, long, float, double. Okay, it's fine. So for all of these, okay, I'll just push them here, and the superclass for them is number. Okay, number has some other subclasses as well. Okay, these are the wrapper classes, but there are other subclasses, like they are in the different package, java.math package. I'm not mentioning the package name here. We have the big integer, we have the big decimal. Okay, there are still a few more. It came in Java 5, or java.util.concurrent package had come, and that time they also introduced one more type called atomic int, atomic long, I'm sure, int or integer, I'm not sure. So atomic long is one of the classes. Okay, so these are the various subclasses of number. Okay, they are all the various kinds of subclasses of number. Why I just brought this one? We have one interface called, there is an interface called comparable. Okay, and this interface is implemented by all of these except for the atomic long. Okay, fine, because there is someone, all of these classes are implementing comparable, right? So there is a specific method available to all of them, which is useful for making comparison between two elements, right? Two long values, I want to make a comparison. Yes, I can make, because it is implementing a comparable. Okay, so there is a method for making comparison. Okay, fine, we'll come to that also later. Fine, so or are you aware of comparable and comparator?
Yes, sir.
Okay, aware of both the things, comparable and the comparator. Right. So fine. So here, this is one thing which is not comparable.
No, sir, we are not aware, sir.
Okay, fine. I'll explain that later. Fine. But the whole point is there is an interface called comparable. Okay, with one method. I'll just mention the method. Compare to. Okay. It's a public method, returns void, no, return type is int, compare to, and takes as parameter. Now there are, I'll have to write in two different ways. One is when comparable was not a generic interface, and then it was object. Otherwise, it's nothing but whatever is the type parameter. Okay, let me. Okay, I'll just mention the whole, it's something like this. In the java.lang package, we have this public interface called comparable of some type T. Okay, and it has this public method. We understand interface has methods which are always abstract. So this is abstract method, return type is int, name of the method is compare to, with a parameter of type T. Okay, earlier prior to generic, this was saying object. Fine, so you make comparison of an object with any other object and it returns an integer value. Okay, fine, so this was one method, comparable. Fine, we'll understand the meaning of comparable later, but just want you to understand that we have number as a class, we have one interface called comparable. These are the various subclasses of number. Okay, one of these subclasses is not a comparable, all others are comparable. Okay, fine. And now let me rewrite this account class again with a bounded type parameter. Okay, now yes, so when I am writing this account class, when I declare this type parameter b is not just anything, right? We want it should be any of these number types. It can be only be a number. Fine. We don't want, see, in earlier case, prior to this kind of this particular declaration which we are going to make, okay, you could have, someone could have said, oh, it's an account of, I want string as my account number type, and I also want string as my type for the balance. That doesn't look good. Fine. That would be valid, right? Compiler would not say anything. But no, this is not allowed. We don't want balance to be of type string. Balance should be of type, oh, those things which we have listed, they are nothing but the subclasses of number. It should at least be a number. Okay? So that string cannot be allowed. If someone wants, he can say double. Or someone wants, he can use long. We don't want someone to be able to use anything other than what is mentioned in that list. These are number as the various subclasses of number. So we want it to be restricted, bounded. Fine. We want the bound to be a number. So we say b extends number. This is what is a bounded type parameter. Here b is a bounded type parameter. Fine. So what is done? B extends number. So if someone tries and uses a string here for the type B, when someone wants to use account of something, and it could be anything for the first type parameter, but for the second type parameter, anything other than number or a subclass of number would be a compilation error. Clear? So we are specifying the one, so as a developer of the class, right, of a generic class, I'm putting bounds on my type parameter. Okay, because now I have put the bound on the type parameter. What is known about balance? Balance is of type B. So what do I know about balance? Okay, fine. Let's say there is some method within this dot balance dot, yes, which methods should I be allowed to use?
Methods that are available in numbers plus.
In number, right? It's not just only object, and now I can even use methods of the number class. Okay, can I make comparison? Can I use the compare to method? Number doesn't have that compare to method. Can I use the comparison? Oh, I want to use comparison also. My method would like to use comparison of numbers. Somewhere I want to be able to compare the numbers. Fine. The logic of comparison is available through the comparable interface. Can I use comparison? No, it only says number, right? I can't use comparison. Compare to method cannot be used. Okay, but I'm dependent on using comparison method. I would like to be able to use comparison method. What should I be doing? I will say Okay, it's not only just a number. It has to be a number which is also comparable. Comparable of B. And comparable is a generic interface. Yes. And that's the reason. So B is comparable with another object of type B. Okay, for simplicity, let me just keep it comparable. But this, so what do, now what happens? We can, the whole idea here is your type parameter can have multiple bounds by using ampersand. Okay. Is this fine? So if someone wants to use account and he wants to use the account number, okay, I think we do away with the first type parameter. Let's just keep one. Okay, and this is only to show that there can be multiple. Okay, fine. Now, so as an invoker, I don't want to be specifying multiple types each time. Account of, what should be the type for the balance? So I can declare account of double. Okay, AC1. Right? Fine. Then it's used as double. B is of type, balance will be of type double. Okay. Fine. It can be used like a number only, but also comparable, because I have now added comparable and comparable. Clear? When any type parameter, B is just a type parameter appearing in that list of type parameters following a class name, right? Syntax wise, it follows the class name, angular brackets. You have to, so, okay. I've just removed for our simplicity in invocation. Otherwise, each time I write account, I'll have to mention two types. Only for that reason. Otherwise, yes, it's always possible to have multiple types, multiple type parameters. Okay, so that part you should understand. But yes, now we can have multiple type parameters, because I would like to be able to use methods other than the methods of just the number also. I want to be able to use comparison also. Compare to method should be available on balance. I'm comparing balances somewhere. Right? Clear? So I want it to be comparable. The whole point is that multiple bounds can be there. You could have added some more, and you could have added, and maybe you want it to be also clonable. You understand clonable interface is there? You know about it? Which interfaces from the Java library you are aware of? Clonable, runnable. Oh, it should also be runnable. So if someone says runnable, yeah. Then, oh, double and all those things will not qualify. One thing, it cannot, they cannot be used. You will have to define a class which is a subclass of number, implements comparable as well as runnable. So I should be having the run method as well. Okay, and then within this, yes, on balance, I should be able to call even the run method. Okay, fine. But whole point here is, here, can I say and give a, okay, now when we have multiple bounds, let me not ask a question, but rather make a statement here. We understand in Java, we do not have multiple inheritance of classes, right? Okay, and therefore, when you are giving the bounds for a bounded type parameter, number is a bound. Okay, only the first one can be a class. Otherwise, it's all interfaces only. You cannot be specifying a class here. You cannot be specifying a class here. They can only be interfaces and not classes. First bound, only the first bound is allowed either to be a class or interface, but other bounds will always be interfaces only. Clear? Because we cannot have multiple inheritance of classes.
Yes.
Okay? Yeah, so when we have multiple bounds, the rule is first bound can be a class or an interface. All other bounds will always be interfaces only and cannot be any class. Okay, anyway, so what maybe our requirement here would be number and comparable. That was just to show the syntax that you can keep on adding multiple interfaces, and accordingly our usability increases. Okay, how we can use this type B, fine, that is what is being enhanced. I have more methods available, I have more functionality on B, fine, that is balance. Balance is declared as B, and therefore I'll be able to use more methods as I put more bounds. Okay, fine, because that's what minimum I understand it will be. It will be at least be a number, but not only a number, it will also be some number which is already implementing comparable, not otherwise. Okay. Fine.
Sir,
Yeah.
like what if I want to say that this extends double or floor? Like I want to have a choice like double or floor.
No, you can't pick only a selected one. There is one feature, okay, which has been introduced in Java 17 or 19, somewhere around that. It's called sealed. No, I think it was in 16 only. It has something called sealed classes and interfaces. Okay, now what you can do is, you can, if you have your own sealed classes and interfaces, you can pick up like this and create your own things. Would you like to understand what is the sealed type? A quick look at it.
Yes, sir.
Okay, sealed types. Okay, sealed types, I'm saying types, right? That means it's for classes and interfaces basically. Okay, so this is right. So you can have a sealed class or a sealed interface. Okay, so we have this. Okay, you know about keywords and difference between keyword and identifiers. Okay, because sealed is a contextual keyword. Okay, there's another contextual keyword, sealed, and so sealed and non-sealed are contextual keywords. Fine, just remember this. Now, the concept of a sealed is something like this. I can define a class or an interface to be a sealed type. Okay, there's one more. Okay, so there are three of them which will be useful in this case. Permits. So if I create, okay, now though it's not the way you, so your idea was double and long, right? You want you want to pick up two of them.
Yes, sir.
Okay, fine. So we can't do it, but I'm going to show you something different here. Okay, so if someone says I have a public interface, oh, it's not just a normal interface, it's a sealed interface. Okay, my numbers, my number types, okay, permits, my long. Okay, so what is sealed? Whenever we use sealed type, we will mention permits and give a list of the subtypes, right? See, with this permits my double and my long, okay, see, it could even have been a class. For example, someone says, oh, it's a class. Instead of interface, I could have taken a class also, but this permits would have been the way it is. Okay, fine. Okay, currently I'm keeping it as an interface. Okay, or even if it is a class, then also fine. Now, because you have mentioned my long and my double, you will have to even mention them here. So you might say, okay, I have a public and a final class called my double implements and give your number. Fine. Have your definition for my double, have your definition for my long. Okay. So if you have done like this, okay, the whole point is, what is a sealed type? Are you getting the idea? When you define a sealed type, you specify the list of its subtypes. Okay, you also declare that this is a super type for only these. Now you cannot have a class, okay, you cannot have a public class saying public class, some class implements my number type. That would be wrong. Okay.
So, like it's restricts the inheritance.
It's a restricted inheritance. Yes. Clear? Sealed restricts the inheritance. Okay. And therefore, when you say sealed, you have to specify the subtypes. And those subtypes also need to be defined. Now, what about the subtype? Can suppose I don't declare it final. Then what will happen? Under my number types, there can be any number of subclasses. But we are saying we are restricting the types. The inheritance was to be restricted. No, it is not, but this one is allowing full inheritance. One thing, this will not compile. A sealed type cannot have a normal subtype. Okay. The subtypes of a sealed type can either be final or non-sealed. Non-sealed, okay. I'm saying subtype because for interface, it can be interface having a subtype which is another interface, or interface subtype can be a class also. Fine. Clear? Subtypes of a sealed types can be final or non-sealed only, and no other subtype. Or they can be sealed, sorry. Yeah, they can again be sealed. Sealed, final or non-sealed. You can't just declare without saying non-sealed. Non-sealed is just equivalent of not making it sealed or final. It's just like keeping it open. Okay, but then they want you to say, yes, you are keeping it open. They want you to declare that, yes, I'm keeping it open. It shouldn't happen accidentally. Okay, so you are not saying final, you are not saying sealed. Fine, you have not said final or sealed. If you just create a subclass and you are saying, okay, of a sealed type, and you don't forget final or sealed, it will give you error to indicate, yes, that you have forgotten to put a final or sealed. Or you knowingly say, no, I really do not want it to be sealed or final. I want it to be non-sealed. Okay, so non-sealed has to be declared. It's just like absence of any such modifier like final or sealed. It's just like our normal classes. Okay, so it's the whole idea is about a private inheritance hierarchy. Fine, I said call it as private inheritance hierarchy. That is what sealed types are enabling us. So you have your own full inheritance structure, okay, which cannot be broken out. Of course, you want it to be allowed to be broken out somewhere, make it non-sealed. Non-sealed cannot be used for some normal classes, okay. They have to be something which is declared as a permits. Only if you have declared it as a subtype of a sealed type, then you declare non-sealed. Normally, you don't declare non-sealed. Clear? Sealed, the concept of, so those three are the contextual keywords which were introduced. Java 16 onwards it has come. Okay. Okay, so fine. So here, why I have shown this is this by this. You know what would be you got the point? How it can be done? What you were asking for, but it cannot be done for the things which are already existing. When you develop your own things, then you can have. Now someone could see with this sealed type. When you had that sealed interface, my number types. So now you could be putting that my number types as a bound.
It's like B extends my number.
Yeah. Okay, B extends my number types.
Okay, sir.
Right? So then you have your own specific. Otherwise, the generic is not meant for that way. Okay, not with a kind of a list which you can have. But here, yes, we can create a list like this with sealed. Okay, and so this was something about the sealed types. Yeah. Okay, so bounded type parameters are fine, right? Okay, let's proceed. Let's check what is there in the yeah, record anyway introduced in Java 16. We will not touch that part. Okay. Okay, so generic class, developing our own generic class with one or more type parameters, adding bounds to a type parameter. Okay, type parameter with multiple bounds. Fine, that we have seen. Okay, so here it is like, okay, there is account.java some type class with a bounded type parameter. Here is the class with a bounded type parameter. Okay, here yes, a slight syntax. If you look at it, A extends number and comparable of A, because comparable is actually a generic interface. Okay, so where we have said, okay, it should be able to compare with A should be comparing with itself, right? For example, you say account class is there, you want account to become comparable, implements comparable of account of A. Okay, if it's comparable, then I will have to use the compare to method. Fine, it's an interface. If you're implementing, then you need to implement the method, right? So here is that. compare to method to compare account. Okay, so type parameter with multiple bounds. We haven't seen the comparable and comparator. That part has to be seen, but then we'll have to now. Okay, so we're going to the collection framework. There are a few things which generic interfaces find bounds. Okay, now generic methods, yes, we got the idea. Just a syntax point of view, we have got the idea. Okay, but we will be seeing more examples when we look at the collection framework. Right? So we will be considering the wildcard inheritance hierarchy, all of those things we will be considering when we look at the collection framework. That time it will become more clear once we have seen the collection set and the list interfaces, right? That time it will be more clear. Okay, we'll be finding good examples for using generics. Another point I have to make here is we are looking at generics to understand the syntaxes, okay, how they work. Fine. Most commonly, as a developer, you may not be required to develop a generic class of your own, but you will be users of the generic classes and interfaces which are available in the library. So you should be aware of the full syntax. Okay, normally you will not be, because the entire java.util package is actually full of all generic kind of classes. There's so many places that you will find this Java library using a lot of generics everywhere. Okay, but as a developer, most of the time when you start developing some application as an application level developer, in an application, no, you will not keep something which is generic. Okay, so developing generic classes or interfaces is normally not what you would be doing, but you would be users of the generic types. So it's important to understand the syntaxes. That's why we have looked at it. Okay, fine. Now let's come back. Yeah. Any questions? Yeah. Okay. Fine. So we can proceed with the collection framework. Okay, I think, yeah, comparable and comparator. Okay. Fine. So first thing, comparable. Okay. Both are generic interfaces. Okay. I'm giving you the abstract method in both of them. Of some element type, okay, some type T. Okay, I think I have given that public it is given something like this: public interface comparable of T. Okay, this is how it is, and it has this abstract method public int compare to, takes T as a parameter, and that's some value. This is it, right? Okay, now this interface is to be implemented by classes. Okay, so this interface has to be implemented by classes whose elements have a natural ordering. Okay. The compare to method defines the natural ordering. Okay, what do we mean by this natural ordering? Let's try to understand this term. Okay, you know comparison, right? How comparison is done? For primitive types, we have the less than, greater than, right? Okay, we use less than, greater than. All those inequality operators are available, right? Fine. Comparison operations. Okay, what about the reference type? If I give you two strings and say, okay, which one is greater, which one is less? Okay. $100 and there's another string. So I want to compare these two strings. Which is greater? 0 or 100?
So it can be like lexicographic or
Okay. So yeah, the way comparison is done for strings, which do you think is greater? 0 is greater, right? Okay. Anyway, fine. So we understand comparison, right? We do comparisons not only with numeric values, but even with other data types. Okay. Fine. Now let me tell you, we have a class called color. Okay, there's a class called color, and for color there are some ready-made objects also, red, green, blue, and other things are there, right? And someone says, now tell me, I have this color dot red and I have this color dot green. Which is greater, which is less? Which is greater, which is less? Do we order colors? No, there is no ordering for them. Clear? The whole point is not everything is comparable. Okay, so comparison logic has been kept separately in a separate interface rather than putting in the object class. Okay, only when you have a class where you feel, oh, we can arrange these, or they have some kind of a natural ordering. See, if I say, oh, you might have developed some very simple class like a class rectangle. Okay, how do you compare two rectangle objects? For greater or less?
by the area.
Why by area? Why not by perimeter? Why not some other thing? We may say they do not have a natural ordering. You can have other ways of comparison. Even with colors, I can be saying, okay, let me go by the intensity of red first and then green and then blue. I will keep those intensities in this order. And then I'll make comparison. So you can have other ways of comparison. Even when I was comparing 100 and 0, let me make a case insensitive comparison. So there can be other than natural ordering also. There are different ways in which your comparison may be done. Okay, but natural order is one thing. Suppose I have these account objects. I have a number of account objects and I give them to you and say, put them in order. I have not mentioned anything else. I just say put them in order. What would you do? How would you arrange them? Account objects. How would you arrange them? By account number. That's why we say it has a natural ordering, because if you don't tell me anything, still I know how to compare them. I know by default this is how it should be done. Okay, so we say this is having a natural ordering. So anything which has a natural ordering should be implementing the comparable interface. So comparable interface defines the natural ordering for objects of the class. So any class which feels that it has a natural ordering, that should be giving should be implementing the comparable interface. Now, what is this int value which is returned? The compare to method is the comparison logic. How it is? So if someone uses like this, right? Okay, let me pick it up like this. So if someone says, I have to, this is compare to, okay, S1 dot compare to, and I might use S2. These are strings, let's say S1, S2 are strings. S1 dot compare to S2, it returns an int value. It's an expression, int expression, right? Okay. Or instead of S1, should I make it A and B? Okay, so we are not implying any particular type, something which is having a natural ordering. Okay, A dot compared to B. Okay, it returns less than 0 implies A less than B. Okay, fine. See, this is the expression, right? How compare to will be used. It has to be used on the class which implements comparable. Fine, and you need to have a parameter which is fine. So the parameter will also be of the type which is mentioned as in the type parameter. So if it is less than 0, return value less than 0 implies A less than B. Return value greater than 0, A greater than B, and returns equal to 0, okay. Normally when it is equal to 0, it should be consistent. We normally try to see that it is consistent with the equals method also. Okay, so for such a case, yes, your equal should also return a true, but may not always happen, but this is what is expected normally. Clear? So is this fine? The meaning of comparable.
Yes.
Right. So the whole idea is, yes, if someone has to compare, it should be something which is implementing comparable if you have methods like that, right? Okay, now, so this is what is comparable. Okay, so classes are comparable. Object of a class, if they are comparable, then they can be compared with object, another object. Okay, for greater, less, or equal. Now, so this will be according to natural ordering, but we might have some other criteria. Even string, right? When I was talking about string, they have a natural ordering which has been defined according to the this here, because these are only ASCII characters. It's according to the ASCII character values, right? The code point values basically. Fine. H has a capital letter has a lower value compared to the uppercase letter, lowercase letter. Yeah. Okay. Fine. So fine, we know that, right? But you want to use a different comparison logic, right? So you want to make comparison of two objects. So you might be having multiple criteria according to which you want to make a comparison. Okay. And then comparator interface. So we use comparator interface for that. Here it was A dot compare to B. Let's see what is comparator interface now. Now this is comparator interfaces in java.util package. It's something like public interface comparator of some type T. Okay, if it is a comparator, that means yes, I have logic for comparing elements of some type T. Okay, and the criteria remains same. It has to return int value. Name of the method is compare, where it has two parameters, T1 and T2. Okay, how do we use it? If I have created a comparator object, right? So I would have some class. Okay, fine. We will have to define some class which implements comparator. Sorry. Okay, fine. Define some class which implements comparator of T. Fine, and create object. Okay. So if we have such an object, let's say C is that comparator object. Okay, then how we use it? C dot compare, and parameter will be a comma b. See the difference between the earlier case? In the earlier comparable, the object to be compared with, right? You call the method on the object to be compared. A is to be compared with B. So I'll say A dot compare to B. Okay. In this case, I have this comparison logic in C. The object is not having the comparison logic. I'm not using comparison logic from the object which is to be compared. But comparison logic is in a separate place called C. Here is the compare method which knows that given these two objects, it will tell me which is greater, which is less. Okay, fine. So if it returns less than 0, it's an integer which is returned. 0 implies A less than B according to comparator C. Okay, clear? It is one specific logic. It's there is one comparator, so one comparison logic is available. According to that logic, A is less than B. Fine. We don't say A is less than B. We don't say red is less than green or something like that. Okay, fine. But yes, there is some logic according to which red will become less than green. Okay, there can be a different logic where the comparison will yield a different result. So these are other than the natural ordering, some other criteria. It could be anything, right? For example, two account objects can be compared. Fine, natural ordering, fine. Fine. So natural ordering for objects of account class may be based on account number. Okay. Fine. Okay. But we may have comparators. Okay. Different comparator objects can be there. Compare by name or by. So another one can be saying, oh, I compare by balance. Fine. So you can decide your own criteria. Fine. Comparison criteria can be decided. Clear? So comparator allows us to give any kind of comparison logic we want. Okay.
Yes.
Okay. And so comparable and comparator. Assuming that you have the, I think you know the account class definition. We will have normally those three things will be there: account number, name, and balance. And you will have the get methods: get account number, get name, get balance. I'm assuming that kind of a class definition. And if you have to write a comparator, how do we write a comparator? Okay. Yeah. Okay. I think there was. Okay. Fine. Fine. Any questions up to this point? Comparable, comparator, is that okay? Comparator, no. Or should I define one comparator and show? Okay. Okay. A few more things about comparable now. Okay. There are some classes. I think you know what is wrapper class, right? Okay. So all wrapper classes implement the comparable interface. Okay. String implements comparable interface. Okay. You know the string class, right? You know the method called compares ignore case, compare to ignore case? No?
Yes.
Okay. Achha, so you are aware of comparison then? Okay. Fine. So now, in that case, let me also show you something here. We have the class called, have you done sorting? Sorting of elements like account elements or any class, whatever you might have developed.
Yes, sir. Employee class by employee number.
You have done sorting that way. And employee class by other criteria. Employee class by employee number, that would be, you might have implemented comparable in that case.
Yes, sir.
Okay. And then you have used comparator also.
Not just overload the syntax, not anything.
Okay. So let's say we take the employee class, right? And since you know comparable, that means, right? Implements, you would have written it is comparable. How did you write it? Compare. Did you use the generic syntax?
Yes, like you have to write employee. Yes.
Okay, because I'll be comparing employee with another employee, right? So this only says that yes, employees are going to be compared with an employee. Okay, fine. Other methods are fine, but you would have written this public int compare to, parameter is employee, and you would yeah. What was your employee number? What was the type?
Yes, type integers.
Int. Okay, and what was the logic here?
Sir, actually, I have used the inbuilt like integer class. Then I passed
Yeah.
int.emp number dot compare to and the receiving int of
Okay. Dot compare to. That means you have used a you must have done the casting.
I have taken the like employee number as integer.
employee number is an integer, that's fine, int, right? Acha, here itself you have taken it as an integer.
Yes, sir.
Uh-huh. Suppose it's not an integer, it's an int, then
Then we have to just take an if else conditions like that.
yeah, and then you should do a cast e dot this dot emp no. Okay, this is to be cast as integer. Okay, dot compare to, because integer, right, the class integer is comparable, this is comparable, and therefore now I am using the comparison logic available for the integer class. Compare to e dot, this will be taken care to convert into integer by the auto boxing. Okay, so that will take care. This is what can be done. Yes. Okay, fine. So this was one, but then what do I want? I want comparison based on names. Okay, assuming there is a field called get, there's a method called get name. Okay. Name comparator implements comparator of employee. We want to be able to compare employees. Okay, it's a comparator which can compare two employee objects. Okay, fine.
Yes, sir.
So how do we do this? This would be public method returns int, name of the method is compare, parameter
Two parameters, employee 1,
and employee 2. And what's the implementation? It's based on the names. Then
E1 dot
yeah,
get name dot compare to E2 dot get.
yeah. Okay, fine. So this is simple, right? So you have written the logic, but how do I then how do I use it for sorting purpose?
Like you have to pass that to collection.
Okay, so if you have an employee array now, right, coming to having something like an employee array. Okay, fine. So this I'm leaving it. Okay, whatever. So you got an array. Fine. How do I sort an array? How did you sort an array?
We have to pass that to the software column.
Arrays class has static methods. Okay, which are those static methods? Public method returns void. It is static method in the arrays class. You are aware of this arrays class? Have you used that arrays class in the Java util package for sorting purpose? Okay. Name of the method is sort, parameter is object array. Okay, fine, that's your array which you are sorting. Fine, so this is one method, but there is one more method. Now let me tell you here. We have still got one more method, which is a generic method. It says, fine, you want to sort array of elements which are of type T. Okay, array of T, that's the array. But then what should I be passing? The logic for comparison, which is available in a comparator. Comparator of what? The arrays of T. It should be comparator of T. Is it this which you want? Okay, here it's not just T. Okay, fine. But for the time being, consider it is T. Though what is there? If you have to see the actual syntax, it says question mark super T. Yeah. So there is a syntax which says question mark super T. For the time being, or anywhere, wherever you are reading this, when you look at the library API, have you seen the documentation? Javadoc documentation?
Yeah.
No? Acha, okay. I can show the documentation if you want. Fine. Because when you read those documentation, it would be writing it as question mark super T. That's how the method signature is shown. Okay. But you can, if you don't understand, you can just ignore that question mark super T and just consider it as T. Okay. Though this is what is the actual syntax. Okay, so for the time being, yes, if you want, you can ignore that, but I'll be explaining why that why the super is needed for comparator here, and what is the meaning of question mark super T. Okay, fine. So this is what is the method signature. Fine. For your understanding sake, yeah, you may just think like this. Okay, so if you are thinking about sorting an employee array, give a comparator for employee. Is that okay?
Yes.
So now how do I do the sorting? Employee
Yes.
comma new name comparator. That's it. Okay. And for name comparator, we have written earlier, right? We have written the name comparator, class name comparator, implements comparator of employee. This one.
Yes, sir.
Should I put it again here? And so just putting it below this, so you understand how the comparator was written. Okay. Fine. So can you shorten this? You don't want to, you have to go back and see how the name comparator was written. So can we have a different syntax here? Can I write this logic here itself?
Like some lambda equation or something.
Okay, lambda also will come, but even before lambda,
Then what is that?
anonymous. Have you used anonymous classes?
Yes, sir.
So that's what is anonymous here. This is what I'll be doing. This, there's no matching this one, I think. Yeah. That's matching. Here, new, your interface name, and then your definition. So this thing you don't have to define at a different place and then bring it here, right? Of course, with lambda expression, we'll see. Lambda expression is for tomorrow, but yeah, then we'll be seeing that there is a better way of, much simpler way. And not only that, later you will find there's still much simpler way of writing this sort method. If you want, I'll tell you what is the final arrays dot sort, assuming this is not, I'm not explaining this syntax currently, okay, but the way it would be done is, that's how you will write the sort. Assuming there's a get name method in the employee. sort the employees by using the employees get name method. The logic for comparison should be, oh sorry, not this one. There is yeah, we have to write this. Yeah, comparator dot comparing. Yeah, that's how it can be done. It is as short as this, and we don't need any such class to be defined. Like we defined initially the class, no, not even the anonymous class will be needed. But this is a different syntax which we will be coming to later at a later stage. But this is how simple it should be. I want to have what this one says is I want to have a comparator which is comparing employees by using their get name method. It is as simple as this. Okay, but how this works, coming to that syntax, yeah, we'll see, right? But this is your initial syntax where you have used the knowledge which you already have, which is nothing but using the anonymous classes. Okay, this is the anonymous class syntax. You are aware of this, right? Anonymous class. Right, this is your anonymous class.
Yes.
अच्छा एक ब्रेसेस कम है yeah, this is the braces for that class. Okay, fine. Okay, so when sort method with that other syntax where comparator is taken as a parameter. Okay, now let's move to the next topic, which is on collection framework. Any questions before that? Yeah. Okay. There are things which I have not done in generic, which is about those wildcards, right? But we'll come to that. Like, what is that question mark super T? Okay, that is where I have used the wildcard. So wildcard inheritance hierarchy, that is part is pending. But yes, we will go to the collection framework, declaring variables of generic type bounded and bounded wildcards. Yeah. Anyway, yeah.
Can we compare two variables which are something?
For example,
start with taken a variable of type A for generic.
which variable of type A is generic. Okay, sorry.
Class account.
Okay. So within the class account, you are talking about within the class account, okay,
Yes.
which is having a type parameter A, sorry, right? So you want to say, you want to compare
Two account numbers.
two, A is of type account number, A is for the account number type, right? And you want to compare two account numbers. You cannot compare two account numbers. If you want, what you could have done is you could have said it extends. So put a bound and say it extends comparable of A. That means it must be a comparable type. So he won't be able to use account of something which is not even comparable, right? Now you can write your comparison logic. Private A account number, right? Okay. Now we know on account number compare to is available. Wherever you want, right? This dot compare to and another account object. Okay. Another this dot, not this dot, sorry, account number. Yeah, this dot account number. compare to, and it could be given an account, some other account object. So suppose you want to develop that, okay, you want to make account itself comparable, where it compares by the account numbers. Implements account, but account is generic, so account of A. Okay, comparable of account of A. Implements comparable of account. Account should be comparing with another account. Okay.
Sir,
Yeah.
A1 dot account number, so I launch, and A2 dot account number, so I string. Then how do we compare that?
Okay, you are trying to mix up. I'll tell you how you are trying to mix up. You are trying to mix up with AC1 here, right?
Yes.
So this is long, right? AC1, and this is account of string AC2, right? They are okay. So here you want to be able to compare AC1 dot compare to AC2. That's what you are trying to say?
Yes.
Okay, fine. Now that should not be working, because AC1 and AC2 are not the same types. This cannot be passed as a parameter to compare to method. It says you, what does compare to require? Comparable of account of A only. You cannot be comparing account of long with the account of string. Because here, what is my bound? I put the comparable of account of A. What is A? For AC1 it is long. So if I am using on AC1, okay, we still have to write one of the method, which is the public method returns int. Name of the method is compare to, and parameter is account, not, yeah, compare to account of A. Okay, it's account of A with which you are comparing. This is your AC, and AC dot account number. Okay, this dot account number can be compared with AC dot account number because A is a comparable type. So I am able to now give you the logic for comparing with based on account number. But this logic has been used for comparing accounts again in turn. See, you are getting the whole thing. A here is a type for account number. But I put a bound saying this cannot be just any type. You must give me something for which comparison logic is there. Okay, which has its own ordering. And therefore, that ordering is used here in this return statement. Account number dot compare to the other given account numbers, accounts account number. Okay, so that is using this bound of A. Okay, and because this class account is comparable, but it is comparable for account of A, not for any other account. Okay, clear? Using that, I am able to write the whole compare to method. Because of that, I am supposed to write a compare to method. Okay, so now if clear, this is long, AC1 is account of long, this is account of string, right? So AC1 dot compare to this is not valid. Okay.
Yes.
Account of long will be compared with account of long, not with other. Fine. Comparable of account of A. It's not just simply A here. This one, this is what you have to remember. Comparable, whenever we say comparable, we are saying account, but when we look at account, it is in turn having a type parameter, so you need to pass a type parameter. Okay. Okay, when there are a lot of to-do exercises, and you should be doing it, right? Okay, when you try it out, and tomorrow we'll check that, right? So if you have, so tomorrow you should be coming with questions on those exercises, to-do exercises, whatever it is. Okay, fine. We are slightly behind, but yeah, we have to look at the collection framework. Okay, we'll start the collection framework.
Okay, sir.
Okay, fine. This collection framework uses a lot of generics. Okay, collection framework is all about data structures basically. Fine, it's mainly concerned with the data structures. Will not take too much of time on this, but on the history and the background part of the collection framework. This is available from Java 2 onwards, 1.2. Okay, most of the collection framework is defined in terms of interfaces. So we have a lot of interfaces. What you find is it's all interfaces. Interfaces, they have abstract methods, right? So through the interfaces, the functionality has been declared in each interface. Right? For example, yes, we have a very general one which says, oh, we have a collection of some element type E. Okay, so data structure holds elements of a particular type. Fine, a uniform type. Sorry. So collection is a very general one. Okay, it has a set of methods. Yeah. So what should be the methods? What methods do you expect in a data structure, which is not even talking about ordering? It's not even ordered. It's a very general level data structure. So what kind of methods do you expect? Let's try to list the methods we would like to be able to in a data structure adding elements. So if I have a collection, right? If it's a collection of string, I should be allowed to add only strings, right? Void, not void, sorry, it's Boolean. Boolean type is the return. For some reason, if it can't be added, it should return false. Okay, add, fine. E, that's the element to be added. Yeah. Just try to see what method should be there. This is a collection, I should be able to add. What else? I should be able to remove. Okay. Okay, or even before remove, fine, you can have the remove method. Remove method will say, you give me any object. It doesn't give the bound, it doesn't restrict you to say, oh, you must always give me that element of type E only. It is a collection of string, but you pass any kind of an object. Okay, fine, to remove it. That object, if it is a string, then it will be able to find if it is there or not. The whole point is how the remove method works. Okay, uses equals method. So it is in turn using the equals method to make the comparison of equality. Okay, fine. So wherever equal becomes true, I'll remove that element from the collection. Okay, there's another method. Before remove, we could have taken that. There's a method called contains. So you can do a checking whether a particular element is available within this collection or not. Okay, and then maybe you want to remove it. Okay, fine. So add, remove, contains. What else? What other kind of operations can be there? Add, remove. Fine. Size. Size. Yeah, size. Then you have a lot of elements, and now you're interested in just getting rid of all of them. Just make it empty, right? Clear. But we have the method called Clear? So make it empty. We even have a method to return a boolean to check whether it is empty. Okay, fine. So we are looking at these are the basic operations available on collection. Collection has its own subtypes. So there are different types of data structure. There would be subtype of collection. Okay, fine. So these three basic operations, plus now you may be interested in having kind of an array. Okay, so you might say, okay, public, give me as an object array, to array. All the elements which you have, convert them into an array form. Or now another generic method has been available. There's a method, it's a collection of E, but we introduce a new type parameter T and say it will return array of T. Name of the method is toArray, but it will take as parameter array. Okay, the purpose of the array being passed as parameter is, okay, there are two purposes. One of the purpose here is to specify what type of elements I want in the array. I want it to be an array of account, I want it to be an array of strings or whatever. Okay, fine. So there are two parameters, fine. And the other purpose of this array here in this case is the array which you pass as a parameter, fine, that will get updated. Okay, the elements in this array will be updated from the elements from the collection. Okay, fine. Now you have got so many elements in this collection. One thing you would like to do is to be able to examine all the elements one by one. We say iterating over elements of a collection. If you want to iterate over elements of a collection, we have something called an iterator of E. The method is iterator. So there is a method called iterator which returns an iterator. This iterator is also another interface in the collection framework. So if I have an iterator of E, now I'm just putting along with the iterator right here itself the methods which are in the iterator. Public boolean as next. And so it's a combination of these methods, E next. So give me the next element. Okay. And there's also another method to which returns void. Name of the method is remove. We'll check why this remove method is there. But what is iterator? Yeah. Okay, let me use a board now. Fine. Iterator, right? So let's try understanding what is an iterator. What's the need of an iterator? What it is kind of. Okay. Okay. So it's something like this. Say you have a collection. Okay, this is some collection. There are various elements which have been added into this collection. Okay, fine. You use the iterator method and get an iterator. So here an iterator object will be created, okay, which is a reference, having a reference to this. It just builds up some indexes for the elements in the collection. So it just keeps the indexes. Okay, it is just building the indexes for the elements which are there in the collection so that it can examine each one of them one by one. Okay, so on this iterator, you will be through this iterator, you are able to examine elements one by one. You are able to check, do I have more elements? Okay, give me the next element. And that's the way you would be examining. Okay, fine. So this much is okay, right? This is okay. Let me write it here. This is your collection, and this is iterator. Iterator keeps indexes on the collection. It has an underlying collection for which indexes are managed in the iterator. Okay, fine. Okay, now how we normally write a code, it is something like this. If I have, for example, if I have a collection of account class, okay, fine. So this is account collection. Okay, let's not worry how the object was created, but for this given type account collection, okay, I can now create an iterator. I want to examine all the elements and say iterator of account. Okay, okay, so that's how you create a get an iterator, and then you want to examine all the elements. You can say for, not for, sorry. Anyway, for we'll see that for syntax is available. I'm not showing you currently. While account iterator dot has next. Account AC equal to okay, and then you do your processing on that account object. Okay, clear. You can, so you are you having a loop, while loop, through which you are able to iterate over all the elements of a collection. If there is a collection of account, that's how you can iterate. Okay, fine. So in what happened was in Java 5, okay, in Java 5 they added one interface and said, oh, collection would extend an interface called iterable of E. So iterable of E is another interface now. Okay, only thing, don't worry too much about that interface. It just adds this method which was already existing. Just created one new interface called iterable and put the same method and said, okay, this is collection is also iterable because it has an iterator method. So anyone who has an iterator method to return an iterator object is an iterable type. So collection was made as an iterable type. Okay, clear up to this point? Collection is iterable.
Yes.
Okay, so if a collection is iterable, what happens here is, okay, you don't have to write the for loop or while loop like this. For you know this, if I have an, suppose I have an int array, okay, values equal to, and I might have some array, you can create some array. Then we know the for loop, how to write a for loop. For each int value in values. You have used such syntax already, right? And you have, okay, so it's this is available, this kind of syntax is available where values is a array, right? Because values is an array, fine.
Yes, sir.
So similar thing is available for anything which is iterable. For whatever the whatever that I'll use E here, okay, element in clear. So this is something which is available, your element will be available. Okay, so the whole point was that instead of writing like these two this whole thing, right, it can be written as, we don't need this, we'll just say for each account AC in account collection. That's it, process AC. Okay, so for each is available for anything which is iterable. Okay,
Yes, sir.
Fine. So collection is iterable, and therefore for each can be used with any collection. But it's not restricted to just the collection. Okay. Now you want to understand, going back to the iterator, right? What is that remove method? Okay. So maybe while before you process, you might have a requirement. So still you might go for iterator, because this is something which will not work with a for loop. Okay. Fine. It's not going to work with the for loop. So still you might like to use an iterator in some cases. For example, if you find that there are some account whose balance is less than 0, you want them to be removed from the collection. Is less than 0. I want them to be removed, and then I will otherwise I proceed with the processing part. Remove and continue. Yeah. How do I remove? It's in the account collection. So should I say account collection dot remove AC? One option is to say right. Okay. But if you do this, there is some problem. Okay. The whole problem here is that the iterator is unaware that's an element which is being removed. It had built the indexes. See why I showed the diagram. This is what is happening. Someone directly removes from this collection. The indexing which was taken earlier is invalid. Clear? Now if you say next or has next, it says, oh, there is something wrong with my underlying collection. Someone has done some tampering somewhere there. The collection has been updated outside my knowledge. See, the iterator should have a knowledge of what's happening here. Okay, so for that reason, the remove method has been provided. So if you do the remove through this, whatever currently you have used a method called next to get an object. So that object will get removed. No other object. It's that object which I've just currently examined. That's the one which I'm removing. So it's removing through this. The indexes will be updated in that case. Okay, and you won't get the error. Okay, so the iterator having a remove method, this is the purpose. Okay, this would not be, this would be wrong. Okay, instead what should be done? Okay, so this should be commented out. This is what should be done. Clear why it is we don't have to remove from the collection directly. Use the iterator. Let the iterator know I'm removing it. Otherwise iterator stops working. Okay, it will throw a concurrent usage exception. Some such exception is being thrown in that case. Okay, and so iterator was one thing. Creating array, it returns an array. Then two array method. Now there are still more methods. There's a public method. Okay, there's a public method called returns boolean. Name of the method is add-on. Takes another collection as a parameter. Okay, coming to this generic part again. Here is a collection of some kind of elements E. Okay, the element type is E. If I have to add now this one is to merge a collection into this. Right? If you are trying to merge two collections, okay, you have got one collection of account, you have got another collection of account. So collection 1 dot add all and collection 2. So collection 2 all elements can be added into the collection 1. Merging, okay, like taking a union. Yeah, so only thing here, my question is, what should be the type of the collection? It's a collection of E in which you are adding. So this should be a collection of which type? Yeah. Collection of which kind of elements?
Is
E only? Okay. Now with E, there is something which is not going to work. The normal cases, yes, it will work. Now, something which should be permitted will not be permitted. Okay, let me. This is the other collection C. Okay, fine. Now, let me explain what will not be permitted. Suppose I have a collection. Okay, so let me write an example here itself. You have a collection of account. Okay, and so we are not worrying about how do we create such a collection, but you have another one which is a collection of savings account. Okay, you know this savings account is a subclass of account here. Okay, so in a collection of account, if I have CA dot add all, should CSA should this be allowed or not?
yes, sir, allowed.
But when you say add all will only take E as a parameter, then a collection of savings account is not a collection of account. Okay, this will not work, and for that there is this something called a wildcard which is used. Okay, what will be used is known as a bounded wildcard. In this case, question mark extends E. I had used earlier also question mark super E in another case, and we'll go back to that case also. So what is this question mark extends E? If I mention C, which is a parameter here, the type is collection of question mark extends E. It's not only E. So this means collection of E type or a subtype, any subtype of E. Collection of a subtype of E is also allowed. But if you don't mention question mark extends E, then only collection of E will be valid. Okay, this would mean only collection in a collection of account, only collection of account can be added. But we would like to allow what? Not only collection of E, but collection of a subtype of E should also be allowed. So this is what is how it is mentioned. Okay.
Yes, sir.
Okay. Okay. But see why this is there is a reason why CSA is not. We understand savings account is a subclass of account, but collection of account is not a super type for collection of savings account. That relation doesn't exist here, because then that would create a lot of other problems. Okay, fine.
Yes, sir.
Okay, fine. So this would be fine. So this is what is the add all method, and then just like add all method, okay, I'll say public boolean remove all. Now here there is a syntax like this. It simply says collection of question mark. What is collection of question mark? Any type will be allowed. Collection for any type. Okay, not just E. While removing, you recollect when remove was done, the parameter is object in remove method. It says here whatever you give, I am going to use equals method to do the checking. If equals says true, then I will find. Equals method object is the parameter, and therefore this is how it is done. Okay. So now here what is being done here is in this method, sorry, in the removal method, the parameter is a parameter says collection of any type of collection is allowed. So it's not restricting which kind of collection it will be. All collections will qualify here. Okay. Fine. Same way, we have the other method, public boolean. Okay. We have another one. I'm just mentioning the methods, contains all. That's having a collection of question mark again. Okay. So what is remove all for? Okay. Let me write equivalent things. I'll write it in terms of A dot add all B is like, okay, in terms of set theory, fine, and more in that terms. A is equal to A union B. Okay. A dot remove all B is like A is equal to A minus B. From A, remove all the elements which you find in B. A dot retain all B is like A is equal to A intersection. So retain only what you find in B, remove rest. Method says retain, okay, but it's about removal. Retain this, but remove rest. Okay. And what is A dot contains all B? B is a subset of A. Right. So these are the abstract methods available in the collection interface. Over and above this, there are other methods which have been added in Java 8. Okay, Java 8 allowed for some more types of methods to be used in a interface. Right? Tomorrow we are covering interface, what is a function interface, lambda expression. So that time we'll come to know about some more methods, different type of methods other than the abstract method, which are allowed in an interface now. Okay, and so then we will add more methods to this list of methods for a collection. Yeah, but these are the methods we have. Array, yeah. To array, this also I think we have not discussed completely. But first method is returning to array, all the elements put into an array, into an object array and returned as an object array. That's the first to array. The second one, I'll just show you how it may be used. Okay, the second format. Okay. Let me put it below this. Okay. It's the second one, okay, not the first two array. First one is doesn't taking any parameter. Okay, So maybe you have a collection of string. Okay. And you might have created a collection how fine with all the names. Okay. And yeah. So you can get a collection of string. Sorry. You can get a string array because return type would be array of t. Okay. Array. Yeah. 2 array and parameter will be. So one of the ways you might do is you will say, okay, new string array of size 0. Even you pass an array of size 0, this is fine. You'll get all the elements in the array. Okay, fine. Now let's say your elements in the collection, okay, instead of 0, suppose I pass 10. What will happen? And somehow some string array has been created, let's say, and you are passing that as a parameter here. What will happen? My strings has a size. Okay. Suppose my strings has the array size is 10. Okay. Now you're saying all names. All names, maybe it has got 15 elements. Okay. There are 15 elements. They all cannot be accommodated in my strings. Right? What will be done is the first n elements from the all names will be replacing whatever my string contains. So my string is anyway updated. Whatever was originally there in my strings, it's going to be replaced. Okay, it will allocate another array of size 15 and name array will be of size 15 because all names has 15. What is returned by the array will at least be of the same size as the size of the collection. Okay, fine. But suppose I have the other way around. So let's take this. Okay. Okay, now let's take another case where here let's reverse the thing. This has 10 elements, but this has got 15 elements. And now if I do like this, yeah. So what do you think will be the size of name array? If the array being passed as parameter here is greater or equal to the size of the collection, then that array is updated and returned. It's not allocating a new array. name array will be of the size 15. Okay, it is same as the initial tell elements will be replaced with the elements. Eleventh element will be a null. That null termination, you know about the null termination which happens in C. Okay, so here what will be done is the 11th element, after the elements from the collection are filled up, okay, I have still got more space. In that case, the next one will be set to null, others will be unaffected. Okay, so this is how it happens. Yeah. Okay, here using the two-array method. Fine. So different cases are there. Normally, the way we would like the normal usage would have been whatever you want to create. Basically, we may even skip this step, and instead, in this, we might just say new string, and in square bracket, you might just allocate all names dot size. This is how we commonly use it. Okay, if we have to use two array, we may use like this. Okay, right. There are other mechanisms which have been added later in later versions of Java. Fine, where two array, one more simpler form of two array has been provided for, but it uses some more syntax, which we will be looking at tomorrow when we look at lambda expressions. Okay, there are other syntaxes. Okay, so this is nothing but a simple collection. Right? So collection. Okay, now as far as the collection framework is concerned, okay, here I am trying to give you the syntax inheritance hierarchy here. Okay, fine. For example, we can start with something like iterable of E. The subtype of iterable is collection of E. Under the collection type, there is something called set of E. There is something called list of E. Okay, list and set. Okay, there's also something called queue of E. Anyway, this inheritance structure would be available from the presentation. Okay, let me just go through the presentation part. Let's see. Collection sort method in arrays. This question mark super T. Okay, that this is okay. This we haven't yet seen. What is question mark extends? So just tomorrow remind me. We can. Yeah. Okay. Okay. Yeah. This is the class hierarchy for the collection. Iterable, collection, list, set. Okay, there's something like queue which has not been shown here. Anyway, queue, and there are those things were added in Java 5 basically. Queue, there's a blocking queue, okay, DQ, blocking DQ. Those are the other kinds of things. But independent of this hierarchy, okay, under iterable, collection, everything, there's something called map and sorted map. So these are the common interfaces from the collection framework. Okay. Collection and okay, iterator to array. And okay, these are okay. We haven't because okay, this is iterator, interface iterator. Fine. Default currently don't look at that default thing. It comes with when we look at interface tomorrow. But these are for a thing called splitterator, collection interface, splitterator interface. Okay. Default methods, you can skip that. Bulk operations, yeah. Add all, remove all, retain all, contains all. Okay. Default methods in collection interface. What is a set? Set is a collection of unique elements, no duplicates. So how set is different from collection? Only difference is with a set it is ensured that there are no duplicates. Use the equals method for equality comparison. Okay. So if you want to know if there is duplicate, that means in a set there should not be any two elements where equals will return true. So it inherits all the methods of collection. We have seen method of collection of E. That's what is being inherited. No new methods as far as set is concerned. So whatever you have seen for collection, that's what is there in set. Okay. Commonly used implementation class. Set is interface, but you want to use actually if you have to have an object, you will have to use a class, right? So has set is the class which is commonly used, which is an implementation of set. Sorted set is a sub-interface of the set, and it manages elements in sorted order using a comparator. And we know comparator now. Sorry. Common implementation for sorted set is the tree set. Okay, and here is these are some static methods. Anyway, this okay, this is about set. How to create a set. Okay. List is what is important, right? So list is something which is quite useful and you should know. It's closer to the array type in the sense that it manages indexes. Okay, elements are ordered and accessible by index value. Okay, similar to an array. Inherits methods from collection, has additional methods for operations based on index value. So these are the additional operations which are added in list. Collection methods are already done, right? So those are available in list. Additional methods is where you can say add. So the first syntax for add is specifying index. That means it's used for insertion in a list. In list you can insert by index position. At this index position, insert an element. Remove available now with the index value. Okay. Fetching an element by using index value or replacing element by using index value. Okay. Searching like using index of or the last index of. Index of means from the beginning search for this object. What is the index? Where does it find? Search from the end. Find. So going from right to left, that's the second method, last index of. Iterator, list iterator is also another interface. It's similar to the iterator. It basically extends iterator, adds more methods to it. And bulk operations, there's additional method is add all. Okay. Okay. And these are static methods of list. Basically how to create a list, that is it can be there, but these lists which will be created are immutable list. This is list iterator. Okay, methods of list iterator. Fine. For list, this is array list is the most commonly used one. Legacy class is a vector class which is used as a list. Okay, so then it comes to this exercise which needs to be done. Update account class to use list of transaction instead of transaction array. So if you have gone through that example which I have sent, okay, it uses a array of transaction. And so we need to update that, and instead of using the array, we would like to use a list, and we'll see how it simplifies the whole code. Okay, see, all these changes are just simplification on the existing code, because we will be using the correct data structure. Okay, so when you use data structures, okay, your code will become simpler. And then will be the map. What is a map? Okay, I think some part we may have to continue tomorrow, I think, because time is over today. Yeah. Okay. Yeah. Okay. Fine. We may continue tomorrow on this. Okay. Fine. So tomorrow, yeah, and we should be starting on time only tomorrow also. Okay. Yeah. But one thing, you can go through the code. There is some to do. Okay. So some of the to do is what you can finish. I think what you can do is related to the sorting part. Equals hash code, writing equals and hash code. Okay. And tomorrow I'll discuss how to write them. Right? We can initially start with that. Okay. And what are the updates needed in that code, and we'll see how the code develops. Okay, fine. We'll continue tomorrow then. Okay.
Okay.
Yeah. So some part is pending from here, but we'll take it tomorrow. Yeah. Okay, fine then. And yeah, you can come up with questions initially. We'll answer the questions initially. Fine. Or you want to have questions now? If you have questions, yeah, you can ask. Yeah, anyone has questions? Yeah. Question even related to the other things was we didn't go through this account class. That was one thing. Okay, let me just quickly, which are the to-dos which we can do here currently, right? So it says to do, override equals and hash code methods. Okay, that's something you should be doing. Use list of, yeah, this is, it uses list. So you can attempt that. If you find okay, you can do that. Yeah, these are all this only. Implement the comparable. This you can do, I think, right? Using local date, this will be pending. Add the method called get transaction. This also is pending still. Has penalty. Yeah, this you can write. No, not all the things. Okay. Anyway, we'll take it step by step. So I think initial first one should be done. Second one you can try out, I think. But comparable, right? Implement the comparable, that you can do. In fact, I had shown already how it can be done. You know the structure. What is the structure here? Account has account number, name, and balance. Okay, it uses it has a passbook to maintain a transaction array. Transaction is a nested class, inner class here. Okay, it currently uses date as type long, okay, which is time in milliseconds. Narration, transaction type, and amount.
Sir,
Yeah, yeah.
sir, you have said that like static methods or static variables can be of generic type. So what is like the inner class is static? So can it be generic type or not?
Yeah. A class can be generic. See, what I have said is it's not that static method cannot be generic.
No, no, ma'am. Sir,
The type parameter cannot be used in the static. See, for a
yes.
class or for a class or even an interface. Okay, the type parameter which is available for the class, right, which is declared for the class, it cannot be used inside the static. Okay, it's only for the parameter declared for that generic class.
So inside a static class, can we use generic parameters?
Yeah. Your static class can be generic. Okay. I
Okay.
think I'll clarify that. Okay. Okay. Let me put it here. Okay. And so this is about the generic. So for example, see, class of some type parameter t. Okay. And in this, you are saying you want to have a, so only thing, if I have a static one, right? Okay. Some static method or even a static class or anything. Fine. Then t's are not available there. Static.
Yes.
I have said class, but it could be even any other static thing. Okay, so even if it's a static nested class, okay, fine. You know there can be a static class. Okay, so fine. This class can be generic in the sense it can say, oh, I want to have a type parameter u. This is okay, but t is not available for top level nested. Okay, whereas if you have an inner class, okay, okay, it may or may not be generic, doesn't matter, t is available here. Clear?
Okay, sir.
That type t is available. Fine, you can declare something of type t in the inner class.
Yes, I got it.
Clear? This, it can have its own parameter again. Okay, v. Okay. Clear?
Yes, sir, clear.
Okay. Yeah. So any other doubts? Yeah. Anyway, it's not that you cannot ask about generics later also. You can anytime you can ask. Okay. And feel free for asking questions. Oh, sorry. I think my mic may have got discharged. It is getting discharged. Yeah. Okay. Anyway, uh, uh, yeah. So someone was asking about main. So I didn't get that point. I think I was asking him to repeat. I didn't get that.
I was saying if you create another method, let's say void method, and key will be accessible there too.
Uh, in this one, you are asking.
Yes, sir. Yes, sir.
Yeah, yeah. T is available if it's non-static method.
Okay, so it can be accessible in everywhere. Like,
It's yeah. It's a type basically. It's a data type that used like a reference type.
and if the method is static, then it cannot be used there too.
Yes. T is not available inside static method.
Okay, thank you, sir.
Okay, fine. This is like we have the enum for transaction type, and then we have the method print passbook. Printf, you want to look at the okay. One more very quickly. I'll have to take because we have taken a lot of time. I'm just opening my browser. Okay. This is the Java documentation, which is actually downloadable. Okay, there is some zip file which is available, and you can download it. Okay, I think I'll find out what is the link from where to get this. Okay. Okay, my mic is getting discharged again and again. Okay. Yeah, this is the Java documentation I was talking about, and so this you should download. Okay, fine. Get the Java documentation. Okay. Uh, so this I was showing about was the one for comparator. Okay, we have seen comparator like this. Anything can be seen. Collection methods. Yeah. Just look at only the abstract methods. Yeah, here it is. Yeah. I think my mic is going off. Okay, we have the this is bank.java also. Here also I've used array basically to maintain all the account objects. And there's a last account number and managed by each bank. Okay, and it manages accounts in an array. So Yeah. Anyway, tomorrow I'll try to explain this again. Okay. Fine, we'll continue tomorrow.